Okay, good day. Welcome back. We're moving on to section 7.4, where we are adding and subtracting rational expressions with different denominators, such as we have in example 1. All right, so I'm going to demonstrate the method for doing this one particular way, and that is going to be this way, where we know the rule when the denominators are the same. When the denominators are the same, then we just add or subtract the numerators. So what I want to do is I want to get the denominators to be the same by multiplying one of the denominators by 1, or the equivalent of 1. So in other words, if this is 4 and this is 8, what do I have to do to the 4 to make it an 8? I have to multiply it by 2. And if I multiply this denominator by 2, I also have to multiply the numerator by 2. So in effect, I'm multiplying it by 1. So I'm changing this first fraction to be 2 times a, which is 2a, over 2 times 4, which is 8. Oh, I forgot the a, 2a. Minus 2a over 8. Okay. Denominators are the same, so I'm just going to subtract the numerators, and I get 0 over 8, which equals 0. And I'm done with my first example. Let's try example number 2. You can go along with me on these in the examples, starting with that page. Let's see, I had another one there, part B. Okay, so this is the problem now. And how do I get these two denominators to be the same? Well, it looks like I could, 10 is a multiple of 50 and 25 is a multiple of 50. So that means I could multiply this first expression here by 5, and therefore making it 5 over 5, while at the same time multiplying this here second fraction by 2, making it 2 over 2. Alright, so this changes the problem to be 5 times 3 is 15 over 50x plus 14 over 50x, thereby giving me a denominator of 50x, and adding the numerators, I'm going to have 29. I cannot simplify 29 over 50x, so I am finished with that problem. Okay, I think I made a little mistake here, because this first one here is squared, right? So that means I would have to do this one over. Okay, no problem. Okay, part B here. I've got another fraction to do, and this is 3 over 10x squared plus 25x plus 7 over 25x, and I want to get these denominators to be the same. So that means I'd have to multiply. I'm looking ahead and I'm thinking, geez, I'll multiply this by 5 and target 50 for it to be the same. And then I'm going to multiply this one here by 2. And I got to make it 2x, because this would make it 50x squared, and the denominator over here would be 50x squared. Okay, so now the rest of that is I want to multiply the numerator by 5 for the left side here, because 5 over 5 is 1. And I'm going to multiply the right side by 2x over 2x. which again is the equivalent of multiplying the second fraction by 1. And now I'm going to rewrite the problem to be, let's say I got 5 times 3 is 15 over 50x squared plus 14x over 50x squared. They should be the same denominator, which they are. And the final answer here is going to be 50x squared. And here I've got 15 plus 14x. And I can't combine those, so I'm going to leave it as 15 plus 14x. And I can't simplify anything by factoring out a common factor where I could simplify it with the 50. So this is my answer here. Okay, that was part B of example 1. Okay, how about example 2? Here obviously they are, well, if we know well enough that what can I multiply to x plus 2, that'll give me x squared minus 4. This is a difference of two squares, and if we remember, I can multiply the sum and the difference of the same two terms to get this x squared minus 4. So I'm just going to multiply this fraction on the right by x minus 2. When you multiply this together, it equals x squared minus 4. So since I multiplied the bottom on the right by x minus 2, I have to multiply the top by x minus 2. And when I do that, now I'm going to have a denominator. Let's see, I think I'll write it over here. My denominator now I'm going to write as x plus 2 times x minus 2. I'm writing it in the factored form in case I can get something up here on top to be factored out as x plus 2x minus 2. But right now, let's figure out this numerator. Here I've got negative 3 times x minus 2, so that's going to give me, I'll do it down below here. I'm going to bring down my 6x first, and then I'm using the negative with this numerator of 3, so this is negative 3 times x is negative 3x, and negative 3 times negative 2 is positive 6. Okay, so I'll combine my like terms here, and I'm going to get 3x plus 6. And from here now, I'm going to factor this. And then when I factor this, this is going to be 3 on the outside, x plus 2 is what's left over. Now this is my numerator. I'm going to put it up top here, 3 times x plus 2, and as you can see now, I've got x plus 2's that are factors that I can cancel out. And what am I left with is 3 over x minus 2. That was fun. That was real fun. I like that. Okay, and that's it. That's for example 2. For example 3 here, I've got two numbers that are just different, totally different. So let's see, what can I do? I can take this 3t and I want to get them the same now. Remember, that's what our goal is here. So I want to multiply this 3t, I'm going to multiply it by t plus 1. And if I do that to the denominator, I have to do it to the numerator. And on this side, to get the t plus 1 equal to t plus 1 times 3t, I'm going to multiply this side by, you are right, 3t. To the numerator, 3t to the denominator. Alright, so I can clearly see my denominators are going to be the same, and I'm going to write them up as 3t times t plus 1. And let's see what I've got for my numerator. So I'm going to distribute the 2 to the binomial here to give me 2t plus 2 plus, what's this going to be, 15t? 5 times 3t is 15t. Combining my like terms, I end up with 17t plus 2. And I can't factor out anything from that, so it looks like I'm just left with it. So this is my answer of 17t plus 2. And remember, we cannot cancel these t's. This t here is part of an addend. Well, this is a factor, so they both need to be factors to cancel. Okay, and here's my solution for example 3. Okay, going on to example 4. Here's my problem with this x minus 3 and 3 minus x. They are indeed, what are they? Opposites. I want to get them to be the same. So I suppose it doesn't matter which one I choose. I'm going to choose this one on the right to multiply it by 1 in the form of multiplying bottom and top by -1. -1 over -1 is +1, therefore I'm not changing that fraction. Alright, so I'm going to, when I multiply this bottom with the distributive property, what do I get? I end up getting this to be -1 times 3 is -3, and -1 times -x is +x. Using the commutative property of addition, -3 plus x is equivalent to x minus 3. Okay, so this now is going to be the denominators. This denominator and this one are the same, and I'm going to bring that over here and write it up as x minus 3. And let's take care of the top part, the numerator. So here I'll try to, let's see, I'm working over here in my space here. I'm just going to bring the 7 over, and then notice what I've got. -9 times -1 is +9. And what am I going to get? 7 plus 9. And that gives me 16. And that's my answer. That's it. So what we did was multiply this denominator, because they're opposite, is -1, and it allowed me to rearrange it to be x minus 3, and they're the same. Example number 5. Okay. What do I have to do to, I just have the 1. What's the denominator of any whole number? It would be 1 over 1 in this case, if I want to look at it that way. And then how do I get the denominators to the same? I have to multiply this 1 by m plus 1. And if I multiply the denominator by m plus 1, I have to multiply the numerator by m plus 1. So what do I end up with? The left side here is going to be m plus 1 over m plus 1 plus m over m plus 1. Extending it, my denominator stays the same, m plus 1, and my numerator adds up to be 2m plus 1. I cannot factor that numerator, so I am left with this as my solution. Okay. Okay, in example number 6, what can I do here to make these the same denominators? Well, first of all, I'm going to factor each of these. Let me factor this left one here, and I can see that an x would factor out, where I'm left with 2x plus 1. Okay, then I'll factor this right side where I can take out a 3, and I'm left with 2x plus 1. Okay, so now to get them the same, it looks like all I have to do is multiply this side by 3 and this side by x. And that will get me, before I move on, if I'm multiplying this side by 3, I'm going to multiply this denominator by 3. I'm going to multiply this numerator by 3. Notice I'm just using the 3, not the 3x, because the x was already there. Alright, so here's my fraction bar here. I got 3 over 3. And I multiply this side by x, this denominator, so I have to multiply this by x. Over here. Here's my fraction bar for that. Alright, so what have I got? I've got a new denominator over here that's going to be 3x times 2x plus 1, and then my numerator is going to be 3 times 3, which is 9, and here I've got, what have I got? The subtraction sign, so this is going to be 2x squared, so it would be minus 2x squared. And again, as far as that numerator is concerned, I can't factor anything out of that, so I'm left with this as my answer. Simplified. All right, our last example, example 7. And again, our first upon observation and analysis, when I've got problems like this, I want to factor. I want to factor them first to get it. It's easier to get them to be the same. So let's see. I know that this is going to be my trinomial factored is x and x here. They're both positive signs. 1 and 1. Right, because 1 times 1 is 1. That's all you can do there. So that's my denominator here. And on the right side, this denominator is, when I factor it, that's the difference of 2 squares. So it's going to be x minus 1 times x plus 1. Okay, so my goal again is to get these to be the same denominator. So it looks like all I have to do is multiply this left side by x minus 1, because I don't have an x minus 1. And then I'm going to multiply the right side by an x plus 1, because I'm missing 1. So when I check this out, I've got 2 x plus 1's, and I got 2 here and 2 there, and 1 x minus 1. Now the only other thing I have to do, if I multiply this side by x minus 1, then I have to multiply the numerator by x minus 1. I should say if I multiply this denominator by x minus 1, then I have to multiply the numerator by the same thing. And here I know I multiplied the denominator by x plus 1, so I have to multiply this numerator by x plus 1. Okay. So what do we know? We know that the denominator is, I'm going to squeeze it in here. Oh, not going to be high enough. So let's see. I know the denominator here is going to be x minus 1 times x plus 1. I'll write it out twice instead of squaring it. And x plus 1. Alright, so that's all our work involved here in our denominator. And now we just got to take care of this numerator. Okay, so I'm multiplying these two terms here, multiplying these together, and that's going to give me, I'll do it over here, 2x squared minus 2x. Alright, that's 2x times x is 2x squared. 2x times negative 1 is negative 2x. And then I'm going to have over here, I'm going to have plus what? And I'll multiply this x times the x plus 1. Distributive property gives me x squared plus x. And next is the only thing left to do, which is combine your like terms. So here I've got 2x squared plus 1x squared, which is 3x squared. Let's see, I better wait before I put it into the numerator there. So I've got 3x squared minus 2x, oh I'm sorry, minus 2x plus 1x is minus 1x. So let me get out of it, let me get rid of that. So negative 2x plus x is negative x. Okay, and can I get an x plus 1 or x minus 1 out of there? I don't think so, but I'll try. So I'm going to factor out an x here, and what's left is 3x minus 1. So I do not have another x plus 1 or x minus 1. All right, so I'll put this one back. It doesn't. You could use this one as the numerator or this one. Doesn't matter. I'm going to go back and put 3x squared minus x, and that would be my answer for that one. All right, very good. That's how you do these rational expressions with different denominators. So thank you for listening, and we'll see you in class.